Could artificial intelligence make your electricity bill more expensive? Every time you ask an AI chatbot a question, generate an image, or create a video, that request is processed inside a massive data center. These data centers contain thousands of powerful computer chips running day and night. They need electricity to process information, store data, and keep their equipment cool. One AI question does not use a huge amount of power by itself, but when millions of people use AI at the same time, the total demand becomes enormous. And AI is growing fast. Companies are building larger data centers, buying more advanced chips, and adding new AI services to almost every product. Businesses use AI for customer service, programming, advertising, research, and data analysis. All of this requires more computing power. Traditional websites mostly store and deliver information. AI systems must perform complex calculations every time a user sends a request. Generating a detailed image or video can require much more computing power than opening a normal web page or sending a simple email. But processing the request is only part of the problem. AI servers produce a lot of heat. If they become too hot, they slow down or stop working. This means data centers also need powerful cooling systems. Some use large air conditioning systems. Others use water to remove heat from the equipment. So the electricity is not only used by the AI chips, it is also used by cooling systems, storage devices, networking equipment, and backup power systems. Now, imagine a large data center being built near a city. It may consume as much electricity as thousands of homes. The local power grid may not be ready for such a sudden increase in demand. Energy companies may need to build new power plants, electrical substations, transformers, and transmission lines. And that infrastructure is expensive. The important question is, who pays for it? In some cases, the technology company pays a large part of the cost. But in other cases, some infrastructure costs may eventually be included in the electricity rates paid by regular customers. This does not mean AI will automatically increase everyone's electricity bill. Electricity prices depend on many factors, including fuel prices, government policies, taxes, weather, and the condition of the local power grid. But if electricity demand grows faster than supply, prices can rise. Think of electricity like any other limited resource. If many new customers suddenly need huge amounts of it, but the supply cannot grow quickly enough, competition for that electricity increases. The situation becomes even more complicated during heat waves. On very hot days, millions of people use air conditioning while data centers continue operating at full capacity. This can place additional pressure on the power grid. Supporters of AI argue that the technology could also help solve the problem. AI can improve energy efficiency, predict electricity demand, manage power grids, and help companies reduce waste. New computer chips are also becoming more efficient. They can perform more calculations while using less energy than older models. Technology companies are investing in renewable energy, batteries, and even new nuclear power projects to support their data centers. But efficiency has a strange side effect. When AI becomes cheaper and more efficient, more people use it. Companies create more AI products, users generate more content, and the total amount of computing may continue to rise. So even if each individual AI request uses less electricity, the industry's total electricity consumption could still increase. There is also a major difference between companies. Some are transparent about their energy use and environmental impact. Others provide very little information about how much electricity or water their AI systems consume. This makes it difficult to know the exact impact of a single AI question. The real issue is not whether we should stop using artificial intelligence. The issue is how quickly AI infrastructure is growing and whether energy systems can grow with it. If technology companies build data centers without adding enough new energy capacity, local communities could face higher costs and more pressure on their electricity networks. But if companies pay for the infrastructure they need, invest in cleaner energy, and develop more efficient systems, AI growth may be possible without placing most of the burden on ordinary households. Artificial intelligence may feel like a digital technology that exists somewhere in the cloud. But the cloud is not floating in the sky. It is made of real buildings, real computer chips, cooling machines, power cables, and enormous amounts of electricity. So the next time you ask AI a question, remember this. The answer may appear on your screen in seconds, but behind it is a physical system using energy in the real world. And as AI continues to grow, the biggest question may not be whether machines can think. It may be whether our power grids can keep up.